Hello everyone, before this video gets started, I just want to remind everyone that our website, studystem.org, is going to be starting its free tutoring for the upcoming semester. So if you need help with chemistry, physics, or biology, head on over to studystem.org and you can view our complete tutoring schedule for the upcoming semester.
Let's get into it. So let R be the region enclosed by the graphs g of x, which is -2 plus 3 cosine of pi over 2x, and h of x, which is given by 6 minus 2 x minus 1 squared. The y-axis and the vertical line x equals 2, as shown in the figure above. And the first question, super simple, is find the area of R. So R is going to be the integral from whatever the starting point, which these tell us is the y-axis, and the y-axis is obviously at x equals 0, and the vertical line x equals 2. So that's super handy. Let me just label this A. They've already given us the two endpoints. There's no work we have to do to figure that out. So then the next question would be, well, what are we actually integrating to get the area? And so I guess the question would be which one of these equations is g of x and which one is h of x. And well, basically the work that I would kind of do to figure it out is the top curve, if you look at it, is kind of a parabola in shape, I guess is what I would look at. And the bottom curve, if you see, it does look a decent amount like a cosine wave. And knowing the graphs of cosine and x squared, you can see that like the parent function over here on the top right, I'll just show the parent function of h of x, or just like negative x squared is like this, yeah. And then a cosine wave goes like this, and so you can kind of see how h of x is the top and g of x is going to be the bottom for that. I hope that made sense, maybe a little convoluted. So basically we're going to integrate h of x minus g of x, just like so. Obviously remember dx, always got to put your dx. A lot of people forget and they lose really easy points off of that. Anyway, so now let's get into actually doing the work. We can do integral from 0 to 2. H of x is going to be 6 minus 2 x minus 1 squared dx. And I'm actually just going to split up the integrals like so. 0 to 2 of -2 plus cosine x dx. Cool. So now that I have both of these split up, we actually will get to integrating them now. So h of x is integral of 6. Well, the integral of 6 is going to be 6x. The integral of x minus 1 squared. The integral of that is going to be x minus 1 cubed. But then you obviously have to, in a derivative, you'd bring that 3 down. So you have to divide by 3 to make sure that all balances out. And then from 0 to 2, then you're going to subtract over here. The integral of -2 is going to be -2x plus 3. Now, again, the derivative to get to cosine is obviously going to be sine. So you're going to have sine of pi over 2x. But now there is chain rule that happens or I guess reverse chain rule, because obviously if you took the derivative of this, you would get a pi over 2, which pops out. And so basically you're going to have to multiply it by a 2 over pi, which would cancel that pi over 2 popping out. Bam, and that from 0 to 2. And if you don't quite get this, if we do 3 sine of pi over 2x, and we take the derivative of that, we would then get 3 pi over 2 cosine of pi over 2 x, and that's because of the chain rule, which makes this pi over 2 pop out. So we basically have to undo that in our integral, which is why we multiply by the reciprocal of 2 over pi on the outside. I hope that makes sense to you guys. Anyways, now we're gonna evaluate these. So we have 12 minus 2/3. This is going to be 1 cubed. Put that in parentheses, and then minus this 0, which is going to be 0 minus 2/3 of negative 1 cubed minus, over here we have negative 4, parentheses negative 4 plus 3 sine, the 2's are going to cancel out, so just sine of pi. Oh, the 2 pi, I forgot about. I'm just going to simplify the 2 over pi into the 3, so that would give us 6 over pi. And in that, we're going to subtract by, this is actually just going to give us 0 over there. And it's 0 because when you plug the 0 into negative 2x, that gives you 0. And 3 sine of 0 is also going to be 0. So that just is going to cancel out to 0. Anyway, going back over here, we can now simplify. This is obviously just 1, so we can basically ignore that. And so we're just going to get 12 minus 2/3 minus this over here. Now this negative, because it's negative 1 cubed, basically just stays as negative 1, so we're actually going to get minus a positive. This is going to become positive, so 2/3, like so. And then over here, it's going to be minus negative 4 plus 6 over pi. Now, sine of pi, if you go back, remember the sine wave starts at 0, and when it hits pi, it's actually back to 0. So, funnily enough, this 6 over pi is just going to cancel out to 0, like so. And so what this is then going to give, this equals 12 minus 4/3 plus 4. And this is just going to equal 16 minus 4/3. You can simplify that if you want, but you can also just leave it. The College Board will totally accept that as an answer. All right, let's go back to this. Now, region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has area of 1 over x plus 3. Find the volume of the solid. Yeah, okay. I'm sorry, I was a little confused because this... Alright, so for B, region R is the base of a solid. For the solid at each... Gosh. Region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has area... Okay, wait, shoot. Stop. Complete reset. Alright, so for B, region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has area A of x, which equals 1 over x plus 3. Find the volume of the solid. And this one might seem a little bit challenging to some people. I know I knew a lot of people who would get really confused over these, but it's not that difficult once you realize that you can kind of ignore the equations they give you at first because they don't matter. All that matters is this area and the start and end points of the integral. So the area is 1 over x plus 3, so all we're going to do is integrate from 0 to 2 of 1 over x plus 3 dx. Now this pretty simple integral, right? This is just going to be equal to the natural log. Absolute values, gotta remember x plus 3 from 0 to 2, which this is then going to equal the natural log absolute value of 5 minus natural log absolute value of 3, which then you can simplify that to natural log of 5 over 3, like so. But you also don't have to simplify that. You could leave it as natural log of 5 minus natural log of 3. The College Board does want you to not leave absolute values in, so if you do want to just leave it like this, you'd have to leave it with parentheses. At least that's what I've been told, is you could leave it like this with parentheses, or you could combine it. Either of those methods work just fine. Lastly, C asks for write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6. Alright, so now it's kind of nice to maybe draw a little depiction of what that would look like. So I'm just actually going to do that on the right over here. So if we think of this, right, this is our y-axis, this is our x, right here, some arrows like this. So region R is like here, right? This is region R. I'm just going to shade that in. And what we're doing is we're taking the line y equals 6, equals 1, 2, 3, 4, 6. So y equals 6 looks like it's just barely there or so. And so our region is going to look a little something like this. This is what we're trying to find. I made that a very messy drawing, but we're going to be finding these loops. It's just handy to draw a picture, I think. Whenever you solve a solids of revolution problem, super handy to draw a picture, always. So, going down, right, we now have that picture in mind of there is a hole in the middle that we're going to want to subtract. So we have the volume, and now this is going to equal, so this is going to equal pi times the integral from 0 to 2 of, now first of all, we want the general area, and the general area here, I shouldn't have erased the picture, let me quickly redraw it. This picture is going to look like that, with, you can see those donuts going through it. So ignore the hole in the center at first. All we care about is, imagine there isn't a hole, and find the area of that. So what we're going to be finding is simply just the area of g of x, basically. And then remember, because it's being raised up 6, basically, or we're rotating around y equals 6, we're going to do 6 minus g of x, because 6 is now, right, this is y equals 6. This is now the upper, or like the top of our integrals, like how in A, the top of our integral was h of x, now the top of it is going to be 6. So that's why we have 6 minus g of x. And now remember, we're rotating it around, so you're going to square that. And dx. And if you're kind of confused as to why the pi's here, or why we square it, the reason is because the area of a circle, right? Area of the circle is pi r squared. And so the idea of it is, well, if you integrated this, you'd be integrating, right, pi integral of r squared. Well, what's the radius? The radius is 6 minus g. That's our radius. And that's why there's the pi, that's why it's squared, everything like that. But this isn't it, because as I mentioned, there's this hole that's created when it's rotated, kind of like a little donut hole. And so we have to make sure that we subtract that from our original equation. I might be running out of space, so I'll just put it right below. So we're subtracting, and again, this is going to be rotated around as well, so we're going to do the same formula of pi, integral from 0 to 2. Now the new question is, well, what's our new radius? And our new radius is going to be, again, it's going to be 6, because that's our upper bound, and now it's going to be 6 minus h, because h is the lower bound on that hole, right? We're trying to find here from this point here to this point here. Well, this point is on h of x. This point's on 6, so it's 6 minus h of x, 6 minus h of x. And again, you square that dx. And you could absolutely box this if you wanted. In fact, I will just do that right here, because all they ask is for us to write an integral. We don't have to evaluate it. If you do want to maybe be extra thorough, extra safe, I know when I took the AP Calc AP test, I hated leaving like g of x and h of x in my answers, and I would always write like what they actually are. So I would write 6 minus 2 x minus 1 squared and negative 2 plus 3 cosine pi over 2x. Like I would go and write those, but you don't have to. The College Board will totally accept that as well. Um, yeah, and so that's going to be the whole problem right there. I hope that was a bit informative. I know I can go a little fast sometimes, but yeah.